Hi guys, today I'm going to talk about how to download, install, and call BLAS functions in C. Okay, let's first go to BLAS website and we download the BLAS functions because we want to use it in C, so we need to use the C wrapper to call BLAS functions. The original BLAS is written in Fortran. Okay, this is the original Fortran code. This one is the C wrapper for the Fortran code. I'll copy it to the desktop. First, we will compile all the Fortran file, Fortran source code, and make a static library of the original Fortran code. We use gfortran compiler -c compile 03 and start.f gfortran, sorry. No such file. Let's try. Yeah, this one is working. Now the compiling is done, we will make a static library of all the object files. We will name the static library as liblas.a, compiled with all the object files. Okay. Now you can see in this folder I think we can find the .a file here. It's just a list. Okay, yeah, it's here. And we will copy this file to the desktop. And we will use it in the future. Yes, now the static library of the original BLAS functions is here. And then we will extract this folder and we compile the C wrapper. First we need to make sure our system, now I'm using Linux Ubuntu, so I need to use this makefile variables definition file. The definitions of the variables in the makefile. But actually this makefile.in is the same as makefile.linux, so I will just edit this file. Edit. You can see here, platform is Linux, the BLAS library, we need to give the directories. I will copy this static library to the C+ folder, this folder. We'll copy it here. Okay. And then here, library over library BLAS.a. We don't need this because we already make the static library, so we can delete it. Use this folder. C+ library lib BLAS.a. lib BLAS.a is right. Okay. Other things we do not need to change it. Okay, we will save this file. And then we need to compile all the C wrapper source code. Type make all. Now it's compiling all the C wrapper code. After compiling all the C wrapper code, it will test all the compilings. Okay, compiling and testing is done. Now you can see here, library. Previously I copied the BLAS library, BLAS static library to this folder. Now, after my compiling of the C wrapper, I have the C BLAS static library here. And then I will use some code, some examples to test my installation. cd examples here. Here to edit. I will first need to edit the makefile here. Makefile.in include all the variables of the makefile, correct? And first it will compile. You can see, suppose we want to run example 1. The CC is the GCC compiler compiling this with C flags, and we compile this C source code. And then after compiling the C source code, we will linking this object file with the two static libraries. One is the BLAS library, one is the C wrapper library. We also say it's C BLAS library. Okay, let's test, make example 1. because you can see I can open this. The example 1 is using the C BLAS header file, so we need to include the C BLAS header file. But the C header file is in this include directory, so when we compile the C source code, we need to include this directory. It's here, C flags. Here it's including the source code. I don't know why it's including the source code. It's not needed, but we really need to include the header file. Okay. Let's compile the example 1. Make example 1. Yeah, it's working. Now you can see this executable. Yeah, it's running. Now I will simply go into this code to explain how this code works. This is just some declarations of the standard C library and this header file for C BLAS. And here we define 2 enumerators. We will use it in the C BLAS function. And these parameters are also used for the C BLAS function. Here is the dimension of the, because this code is used for matrix vector multiplication. Here is defining the dimension of the matrix and the vector. Now it's allocating memories for the matrix and the vector. Now it's initializing the elements of the matrix and the elements of the vector. Here it's calling this function, the C BLAS dgemv, this function, to do the matrix vector multiplication. Here it's printing the result. Here is free all the memories allocated we have allocated before. Yeah, this is just a simple introduction for this code. It's very simple, but probably you will wonder why here the programmer defines something like this. Where does this come from? This enumerator type is coming from a header file, because we are calling this using this cblas.h header file. These variables are defined here. These things is already defined in the header file, so we can directly define some variables in our source code. Okay. Now let's compile the example 1. Hopefully it will work. Big error. No such value. Yeah. I need to, because here I include the header file library. Here I also need to include the header file library. Copy it here. It's working. You see this executable. Let's run this. Yeah. The code is running very well. So I also did another example to do matrix multiplication. The source code file is on the desktop. I will copy it to the example folder. I will briefly explain how this code works. The style is very similar as example 1. First we define some enumerators, and then we define the pointer of the matrix and the parameter, the scalars for the matrix multiplication, the dimensions of the matrix, and allocate the memory, initialize the values of the matrices, and then we do matrix multiplication using this C+ function. So how do I know? The only problem here is, how do I know I can use this function to do matrix multiplication? Because as we all know, in C programming, every function is defined in the header file. So we can go to the header file to see all the functions we can use in C+ library. I'm using the BLAS level 3 functions, C+, this one, C+ underscore DGEMM. I simply copy this function to my code and I change it by myself. Yeah, that's the way we are trying to use a function at the first time. Okay, the matrix multiplication, the equation for this operation is alpha is scalar, alpha times matrix A times matrix B plus beta is a scalar times matrix C. The result is equals matrix C. So we can also do operations on A and operations on B. The operation is we can do transpose of the matrix. Okay, let's run this. Oh, sorry, I forgot one thing. Suppose we need to compile this source code, my own source code. So I need to copy the compiling command in the makefile and edit it by myself. So my source file name is C+ underscore matrix mult.c, and the object file will be C+ matmult.o, and output I want to output to a name of C+ underscore matmult. Yes. Okay, let's try compile this code. The makefile command, I want just to use matmult. It seems like it's not working. Let's check. C+ matmult.c, C+ matmult.o. Let me try it one more time. Same. Then include the header file BLAS MUT. Okay, wait a minute, I will figure out this problem. Sorry, I think I just forgot to save this makefile. I added it, but I forgot to save it. Now let's try it one more time. Now it's working. Let's run this. Yeah, it's working. Okay, this is the simple introduction on how to download, install, and call C+ functions. Hope you get an idea of how to use it. The basic idea is you compile the original Fortran source code, BLAS source code, and you make a static library of the Fortran code, and then you compile all the C wrapper source code and make it a static library, and you can write your own code, including the header file, C+ header file. Use the functions defined in the C+.h header file, and you compile it. After compiling, you link your source code object file with two static libraries. One is the original Fortran source code static library, and the other one is C wrapper static library. Okay, I think this is done. You can try it by yourself. If you have any problems, please leave any comments below.